This is a video for MEI Core Pure Mathematics, Hyperbolic Functions, 1.2 Solving Simple Equations. We can solve simple equations involving hyperbolic functions by substituting their definitions in terms of e to the x and then manipulating the resulting equation. We can also use the inverse hyperbolic functions, but we will see those in a later video. Let's look at this equation. Cosh x we know is e to the x plus e to the minus x over 2, and that's equal to 3. So I'm going to get that e to the x plus e to the minus x is equal to 6. And multiplying through by e to the x, I get e to the 2x plus 1 is equal to 6 e to the x. Rearranging then, e to the 2x minus 6 e to the x plus 1 is equal to 0. Just look at this a little bit more closely. Think of this as e to the x squared minus 6 e to the x plus 1 equals 0. And this is effectively a quadratic with e to the x as the variable. Something squared minus 6 times that thing plus 1 equals 0. I can solve that quadratic a number of ways. I could use the formula, I could complete the square, and for this one I'm going to use completing the square. So I'm going to look at e to the x minus 3 all squared, and that's going to give me an extra plus 9 at the end, so I need to take that off. Plus 1 is equal to 0. That's going to give me e to the x minus 3 squared is equal to 8. Square roots of both sides, e to the x minus 3 is equal to plus or minus 2 root 2. And so e to the x is equal to 3 plus or minus 2 root 2. Now we know that e to the x has to be greater than 0. And here if we have a look at this thing, well, root 2 is around about 1.4, so this is going to be around about 2.8, and this will therefore will always be greater than 0, so I can keep both parts of this. So taking logs of both sides, I'm going to get that x is equal to the log of 3 plus or minus 2 root 2. That's the algebra worked through a bit more tidily for you. There's my quadratic in e to the x. There's my solutions for e to the x. And there's my solutions for x. If you look at the graph, you can see the red line is cosh x, the green line is y equals 3. And I've got two values for the intersection. Let's look at this one. Similar technique. Cosh x is e to the x plus e to the minus x over 2. And that's plus two lots of sin x, which is e to the x minus e to the minus x over 2. And that's equal to 3. These will cancel. Let's just tidy that up a bit. So I'm going to get e to the x over 2 plus another one is 3 e to the x over 2, and I've got an e to the minus x over 2, take away another e to the minus x, so I'm going to get minus e to the minus x over 2, and that's equal to 3. Multiply through by 2 and e to the x, and I'm going to get 3 e to the 2x minus 1 is equal to 6 e to the x. And rearrange, I get 3 e to the 2x minus 6 e to the x minus 1 equals 0. Now again, I could use a variety of techniques to solve this. This one actually is probably better with the formula, and I'm just going to give you the result here. So this is going to be e to the x is equal to 1 plus or minus 2 root 3 over 3. Now we need to do a little bit of a sense check here because we know that e to the x has to be greater than 0, and this 2 root 3 over 3, well, that's about 3.4 on the top, 3 on the bottom, so it's going to be bigger than 1. 1 minus this number could be negative, so I'm going to drop the minus sign because I can't have e to the x being less than 0. And therefore x is equal to just one solution, the log of 1 plus 2 root 3 over 3. Again, there's the algebra worked through down to our quadratic, and there's the single solution because e to the x has to be greater than 0. And on the graph you can see there's only one point of intersection, and hence only the one solution. The next video in this sequence is 1.3 hyperbolic function identities.